Hi, very good evening, everyone. Can you hear me well? Yeah. If you don't mind, I'll proceed in English. That's my language for professional work. So thanks for the kind introduction to begin with. Just wanted to thank all the organizers of this event for inviting me and for giving the time to give this presentation. So I'll just go into this. This will not be a technical presentation. So this is the end of the day today, right? I think you're all tired of the differential equations and all the like. So there will be no technicalities here, right? And actually, I'll talk about so AI in general, but explainable AI in particular. I don't assume that you'll have, I don't assume any particular background in that. That's why I'll keep it a very high level here, and there will be not that much math, so to speak. But I'll try to tell you what's happening in AI, what's hot in AI for those who are interested in that. Right. So just briefly, I'll say a few words about me and why I'm here. I'll and then go on into explainable AI, kind of as an aspect of trustworthy AI. I'll spend just a few minutes on trustworthiness in general, and I'll try to give a very high level overview of that. Which will amount to, saying what explainable AI is. So XAI is the shorthand for that. Some activity that's around it in AI conferences and elsewhere. And I'll try to give an example as to how it works, for instance, in the telecommunication sector, given that I'm representing today to a certain extent Ericsson research, where I'm from currently, where I do my research, but it doesn't have to be telecommunications in particular, just an example. And that's it. Maybe I might just skip the very end of it. So let's try again. Yeah. Okay, I can move the slides now. So just briefly then about me, you might be wondering why I'm here. I'm kind of a researcher in AI, so not maths, but I don't shy away from maths. I've actually done maths. First 2 years here at this university, I had the pleasure to be taught by Professors Kristijonas C and Rungilas and others as well. So did a few years here in pure maths, and then went to do maths at Warwick University in the UK. I did pure maths, logic, and then went to logic and maths masters, and then finally did a PhD in computer science. That's at Imperial College London. So unfortunately, I cannot call myself a mathematician. I don't have a PhD in maths. I cannot call myself a computer scientist either. I don't have albeit I do have a PhD. I don't have a proper education in computer science. So I'm neither here nor there. So forgive me for that, but anyway, I'm just somewhere in between in AI and maths, and I'm doing explainable AI, and maybe that explains why there's not going to be that much maths in here. Okay, so let's just jump right into it. So trustworthy AI, that's a kind of a vague term. That typically amounts, at least in European Union's perspective or Commission's perspective, to ethical AI to a certain extent. Basically, we want our AI systems to be, good for us, for humans, and trustworthy and whatnot. There might be that kind of, plenty of considerations. Let's say you put forward that, there are at least four principles, ethical principles for the trustworthy AI, like foundations, which amount to something like respect for human autonomy, prevention of harm, safety, fairness. So we've heard about fairness in the previous talks as well. So algorithmic fairness, basically, and explicability or explainability, as I'll say, as I'll use in this talk. So in technical terms, here I'm not going to cover, trustworthy AI at all. I distinguish three technical aspects of trustworthy AI as such. I mentioned safety. So AI should not do harms to humans as humans and environment as well, roughly. Algorithmic fairness being about discrimination on non-discrimination in algorithmic decision-making for individuals or economic entities based on their features and other preferences. So that's about that. And here we're talking about explainable AI, and we'll jump into what explainable AI, what explainability is. But those are the three aspects. This is the key one that I'm interested in. There are more things in trustworthy AI in general: robustness, privacy, security, other things that kind of mix and match. And nobody has clear definitions about that. I just want, the takeaway is that at least explainability is quite well studied and, to a certain extent agreed upon term. So that's what we go into. Okay, so what's explainable AI? Intuitively, explainable AI comprises kind of endeavors to make AI systems intelligible or understandable, primarily to us humans, but in principle to any users of those AI systems. Those can be machines. It's basically an interdisciplinary field of research. You know, it's AI, that is human-computer interaction, sociology, philosophy as well. There's lots of maths, natural statistics, and so on and so on. It's hard to say, you know, what it exactly encompasses, but you know, it's really interdisciplinary field. Not limited to computer science. But basically the goal of explainable AI is to define methods and approaches that would provide explanations for a given AI model or a system to kind of make it more trustworthy. So explanations as to how it works, why it produces the output that it produces, and so on and so on. So that's at a high level. And I just wanted to say that, again, given the audience, explainable AI, so explainability, is a really, really hot topic within AI. So we know that AI is a kind of, you know, big with, you know, all the advances in machine and deep learning and hybrid approaches and so on and so on. Explainability is one of the kind of, you know, big key topics, and there's lots of activity in there. So you can consider academic activity, biggest conferences, enormous amounts of publications, growing and growing, workshops, symposia, journals, and so on and so on. Also, you know, industry is engaging in that a lot as well, into academia and on its own. You know, both the fact that there are plenty of startups focusing simply on explainable AI, not just, you know, applying AI, but, you know, promising some explainability features in, you know, platforms and so on. But also, you know, all big firms need to have white papers on AI, including explainable AI, you know, Google and so on and so on. And there's lots of societal activities, right? You know, there's defense agencies programs, European Union is very much interested in that, commission, and, you know, other groups and so on and so on. So it's quite important as a I don't know, subfield of AI or whatever as a topic. So one key takeaway. Just wanted to say also that, you know, many of you might have heard of explainable AI from the point of view of black boxes and interpretable machine learning. That's definitely a problem nowadays. You know, you have machine learning models, paradigms that work not on something like simple linear regression, as we heard, you know, some negative comments regarding, but, you know, more complex models and so on and so on. We want them to be explainable. That's for sure a problem, but there's also the whole area of so-called machine reasoning research that dates back from old, you know, symbolic AI days, expert systems, those who have heard of those. And, you know, it includes things like constraint programming and solving. So, you know, many equations, whatever constraints, logic-based approaches, discrete maths, and all of that. Explainability has actually been investigated there for years, and it's kind of been a resurrection of that nowadays with different problems, obviously. But it's really, it has been a prominent topic within AI for a long time, so to speak, for several decades. So it's not completely new, and it's not only about machine learning, by the way. It's really important that, you know, explainability is in many other approaches to AI approaches and systems. Okay, so this will be the most technical slide, maybe. So just to give a rough picture as to what an explainable system, AI system, amounts to, what is the goal of the research within explainable AI, so to speak. So what we want an explainable AI system to do is to produce some details and reasons underlying its functioning and outputs. And I'm mentioning here both outputs, so input-output behavior, as well as functioning, so the models. Pictorially, you know, you can imagine that you have an AI system somewhere, that's AI model in there. I don't know if I can use the laser, yeah, but that's it. It consumes an input, could be data, it could be a query, you know, it could be constraints, some knowledge or whatever. It could be a robot planning something, so it consumes, you know, visual percepts or whatever else that is, produces an output. That's your typical scenario. You have a system that consumes input, produces an output. Explainability comes on top of that, where you can imagine a component within the system, an explainer component, that is supposed to take the model, presumably, or some parts of the AI system itself, some description, representation of that, as well as the input and output, and produce an explanation regarding this particular output or the functioning of the system. This explanation, as well as the output or the answer, is given to the user of the AI system. Could be a human user, could be a machine user. And there's also typically implicitly or explicitly a question that this explainer answers about the AI system. You know, why did you give me this output? Which input leads to this output? How did you learn this model? Which parameters were responsible for this convergence? Which, you know, something like that. So along those lines, I'll come to examples in a minute. But that's roughly the picture. So we have an AI system, and we have an explainer that produces some explanations about the outputs and or functioning of the AI system to the user of the AI system, so that the user can act upon that explanation. I mean, the user can learn something, but you know, you can obviously act. You can debug the system. You can, you know, play with your data, maybe inputs or something like that, whatever, or you know, make other decisions. So that's at the high level. Just, you know, I'll try to give a few examples. Not sure how much bell of, you know, how much will it be of a ring of a bell, whatever. Sorry for how familiar they might sound to you or not, but I'll try to, you know, give this the following example. So from a telecommunication sector, so telecommunications is your phones. You know, you talk on a phone, right? That's your mobile, you know, signal, internet, whatever. That's how, you know, mobile internet kind of travels through the air. That's how you would watch, let's say, if you were watching, I don't know, something on YouTube, not on Wi-Fi, but in the mobile internet. That is, you know, YouTube is served somewhere. There is some server that actually is running whatever is on YouTube, you know, there's material, and then it flies over to you, to your phone or whatever, where you're watching that. It flies in the sense that there are equipment in between, you know, there are servers, there are routers, there are those base stations, radios that are, you know, beaming the beams, you know, the internet or whatever, and they give you that, you know, that YouTube there, right? So you're watching that and you have a certain quality of experience there, right? You know, you have certain latency or, you know, certain quality on your phone screen and so on. And that's, you know, you like it good, right? You know, so YouTube is your service, let's say, that is deployed on the network, that is a physical network of devices, which is, it has a digital kind of, you know, print or twin, so to speak, which is managed automatically by AI systems. Well, at least that's in theory, as to how, you know, this YouTube is given to your phone, you know, how, where you route it, how much resources you give in one place and another one, and so on, so that everybody is happy watching their YouTube or whatever, where the service is actually running in multiple servers and so on, and cloud or whatnot, right? Now, so there's, I just mentioned that there is, you know, AI basically there that manages this, right? You need to allocate your resources somewhere. And this is where a kind of explainability comes in. If you just have an AI that is kind of managing all it, surely things don't go well all the time, right? You know, there are crashes, something breaks down, you need to fix something and so on. And even in a more interesting scenario, you're actually, as somebody who is playing YouTube to your users, you want them to always be happy about, you know, the quality. And if many users, you can imagine that if many users tune into a particular, I don't know, YouTube channel, or, you know, 5 o'clock in the evening after work, they tune in to watch something, there's lots of load happening at the same time, or maybe in events and so on, and you may have degradation in your quality, you know, latency or whatnot. You want to preempt those things. And modern AI systems are actually there managing this supposedly managing with this without human intervention. And they need to both, you know, kind of see what's happening, fix things, and also on top of that kind of explain to human users why things are happening, because, you know, somebody needs to kind of oversee the system and see why resources are allocated in one or another way. So that's a high level, but I'll try to just give a few examples in a few minutes of, you know, 3 kind of tasks in this network. So, you know, I'm watching YouTube, right, or whatever video stream, and there's lots of users may be tuning in to a certain point, you know, area and so on and so on. one task for an AI, and typically these would be machine learning models, would be to predict how much traffic there will be in a particular situation, right? How many phones there will be and they will be consuming internet, because that will affect the traffic, right? You need to increase the resources or whatever. So that would be one task of, kind of predicting what's going to happen. Now, suppose you predict that there's going to be lots of users and you will not be able to serve the service at the good level that, the same level that you're serving now due to resource constraints. Then you need to do some sort of root cause analysis, right? Why is it the case that you don't have resources provisioned yet for this increase in the traffic and so on? Maybe something broke. Maybe you find that, some port or router or whatever got congested, something else did happen. And so you need to root cause that in order to resolve that kind of problem, if there is a problem. Typically, there are problems. And then finally, once you know where the problem is, you need to re-optimize. You need to allocate your resources somewhere, right? Maybe new servers, whatever. You need to find this, reroute the traffic. This is all happening live, by the way. So it's not like you do it like upfront, there or something like that. So those are the three problems. And you can imagine, I'll just briefly tell you that there are, explainability issues in all of those. So suppose I'm predicting something that is happening, say lots of my models are predicting that there's going to be lots of traffic, at certain point or whatever, and there's going to be a problem. Well, why? This is based on some readings in the network and past data. So explainability could answer questions as to, which particular data features, let's say, are pointing to the fact that there's going to be lots of traffic. Is it that some mobility traffic that users are moving around somewhere? Is it gonna, is there a predicted event somewhere where lots of people have, or, maybe there are some readings of the equipment that would point to something, that something is gonna break or whatever. And this comes to the second point of root cause analysis. You could be predicting that there's going to be a problem, and the prediction with explainability might point to the fact that some server has gone down, right? It's just not responding, not giving you the traffic or something like that. So that explainability might help you to, to do some root cause analysis, which you would typically do with some, logic-based systems, maybe constraint systems as well, where you know the specifications of your devices, and then you say, okay, something is, there's a fact that, you set a variable that something is going wrong, and then, okay, how do I find the cause of this variable, of this particular value, or something like that. So explainability would answer the question if you have this AI system that's saying, well, the root cause is some server. You could ask, how did you get there? What's the knowledge? What are the facts that you're using, and so on and so on. And then finally, so you need to fix that, right? So suppose you know what to fix, you have your constraints, maybe some router is malfunctioning or a server, and then you can solve a constraint problem that, just allocates, minimizes certain, costs and maximizes the throughput, whatever, and allocates resources. And then you can ask a question, so that's your output, right? So it gives you a solution, but then you can ask a question, but why is this output rather than another one? Maybe I wanted to reallocate because, the Pareto front or whatever is big. There are lots of potential solutions there. You could ask questions as, maybe I want this kind of solution. Or if you are in the case where the solver or whatever it is says, well, you cannot provision the service anymore, YouTube or whatever, because of, broken server, then you could ask, but why? What are the minimal reasons? Show me what the kind of, what are the minimal constraints that I'm violating that I no longer am able to? And can you also show me how to relax these? Can you show me that, maybe I'm insisting that my latency is very low in the network, but can you, so that might be the case. And an explanation might be that if you just were to increase it a little bit and let your users be, a little less happy with latency, but still, meeting other requirements, you would be able to serve the service in that way. So explainability is actually would be a method that would provide, explanations, answers to this kind of question. How do I change my requirements so that I achieve the desired state, or, as close to desired state as possible? And then this basically comes into one big picture, pipeline in a single system. And so this example is just a very high level example, and I'm not going to go into any more of this, but just wanted to illustrate that there are, the kinds of explanations that we're looking here, are kind of, on the one hand, attributive explanations. You can ask your machine learning model, why are you giving me this prediction or this classification? And then attribution amounts to pointing to features that influence the outcome. That those are very typical scenarios. Or in different systems, you could point to knowledge that leads to some inference in there. Maybe give a proof within that system that this is, this is what is happening. So that's kind of explainability. Another kind of explanation is a contrastive one. So, why not a different outcome, right? I see this, but why not something else? What are the variables that prevent that? You can imagine a bank loan. I know it's does, we have a Danske as a sponsor here. You can have a bank loan algorithm that, gives or not gives a loan, right? And you could ask, okay, I'm not getting a loan. That's my output. Can you explain me why I'm not getting a loan? And an explanation could be something, well, you're too young. Maybe your age bracket is the wrong one, or maybe your salary is the wrong one. And the salary is something that you may potentially be able to modify, right? If this is, if this is the feature that's preventing you from getting your loan, maybe if you were to work harder, I don't know, whatever, you could get bigger salary, maybe you would get a loan. And it's a cooked up example, but, and it's not really real. Well, you correct me if I'm wrong, but it's roughly at that level. And that's kind of, goes into this actionable space, right? What can I do to actually change the output of the AI system so that it is desirable the one that I want to get. Okay, I will not go into this. I mean, so you can just want to say that, explainability is both for machine learning and machine reasoning, and interplay between the two, right? You have explainability of machine learning models that might inform your root cause analysis. This might in turn inform your resource relocation, and so on and so on. So there's interplay and there's explainability for all of that. And also that, it's not only machine-human explainability, as I tried to allude in this example, it's also machine-machine explainability, right? It's not only humans that need to know why things are happening. Sometimes the other AIs are benefiting from the information that is provided as an explanation as to what currently we understand within explainable AI approaches, from that information to make new inferences. And so finally, just, basically in terms of trustworthiness, the idea is that in order to make our AI systems trustworthy, to us, whatever that precisely means, we aim to include explainability and do explainable AI by design when designing those systems, basically. That's kind of, one of the key consensus points that, explainability is an important part of trustworthiness, and that it should be there in those systems in one way or another, at least in critical situations, application scenarios. And that's it. So these are resources if you want to consult those. Most material is public there. You will find it somewhere there. I can leave you with those, or maybe you can fetch the slides later on. And that's it. Thank you for your attention. Happy to take any questions. Can we take questions in Lithuanian or English? I don't mind. I can translate if you want to.
Thank you, Kristijonas, for interesting talk. Are there any questions in English or Lithuanian? There is one.
Gal čia ne klausimas, tiesiog komentaras. Aš jau 5 metai kaip dirbu finansuose ir dirbu rizikos srityje, kur mes ten skaičiuojam rizikas, skaičiuojam vertės, kainas ir žodžiu, bandom kontroliuoti rizikas. Ir nuo to laiko, kai pradėjau dirbti, ta tema, kad galbūt būtų gerai taikyti artificial intelligence, machine learning, jinai buvo taip aktyviai nagrinėjama ir lig šiol, ir per tuos 5 metus lygtais nieko labai nepasikeitė, nes būtent dėl to, kad dėl to explainability. Tai yra iš tiesų labai aktuali tema, nes kai finansuose taikome tos modelius, svarbu paaiškinti, kodėl davė tam tikrą tą rizikos pamatavimą, nes jeigu tu negali paaiškinti, tai tu negali pataisyti modelio, kad kitą kartą jis skaičiuotų gerai. Tai čia tas turbūt principas ir yra, kad mes norime suprasti, kaip gaunasi atsakymas, kad mes galėtume pakoreguoti, kad kitą kartą gautume geresnį rezultatą. Tai va, jeigu mes negalim paaiškinti, kaip mes tą galutinį rezultatą gaunam, tai mes negalime ir pataisyti modelį, kad jis duotų geresnį rezultatą. Tai šita visa esmė ir tai tikrai finansuose dabar daugėja tų modelių, daug dalykų skaičiuojama ir aišku, artificial intelligence kompanijos jos labai norėtų užimti tą rinką, sukurti tos modelius, bet dar nepatenka, nes būtent dėl šitos problemos, kurias čia pateikė. Tai tiesiog ačiū už prezentaciją ir toks komentaras.
Ačiū. Labai geras komentaras. Iš tikrųjų, iš tos perspektyvos aš greitai pasakysiu. Taip, viena iš problemų ir vėlgi, kam yra skirtas Explainable AI, paaiškinamas dirbtinis intelektas. Tai gali būti naudotojams, tiem, kurie gauna kažkokį produktą, rekomendaciją iš Netflix ar banko, ten kažkokį nusprendimą ar panašiai, bet tai gali būti arba tie, kas riziką nustatinėja, bet tai gali būti, aišku, tiem, kas tos modelius kūrė ir taip toliau, taip, kad jos padarytų geresnius arba kad pataisytų ir panašiai. Ir daug kitų yra auditas ir panašiai. Tai čia vienas labai geras aspektas, o iš tos bankų perspektyvos tai iš tiesų, tai yra tiesa, kad bankai yra susidomėję ir aš žinau, kad taip, ta problema ten egzistuoja. Žmonės viduje, kurie sukuria, bando naudoti naujus, ypač komplikuotus dirbtinio intelekto metodus, neuroninius tinklus ar panašiai kažkam, kas veikia geriau negu tuo metu veikiantis decision trees ar panašiai. Jie gali tai daryti, bet jie negali to lengvai paaiškinti tiem, kas patvirtina tos modelius. Ir tai tada susidaro problema. Tas, kas valdo fondus, gali būti netoks patenkintas. Ir dar pridėsiu tiesiog, kad gerai pasakei, JP Morgan neseniai, vienas didžiausių bankų turbūt pasaulyje, prieš 2 metus atsidarė centrą Excellence for Explainable AI ar kažkas tokio, dirba su akademija, su dideliais žmonėm ten ir bando tai daryti. Jau keletą metų tai daro, tai nežinau, ar jiem ten labai kažkas pavyks, ar gal dar ne visai, bet tai yra sudėtinga problema, dideli pinigai, dideli žaidėjai tame žaidžia. Ir vėlgi, čia klausimas yra, ar kiek Lietuvoje bus galimybių irgi tą daryti, kiek reikės tam ir kiek bus galimybių užsimti šituo. Tai irgi tik tai komentaras, nieko daugiau šį gero nepasakiau.
Explainable AI pavyzdį galėtume duoti tokį, to pačio matematinio modelio pavadinimą, kuris priklausytų klasiai Explainable AI.
Jo, žinoma, aš nenorėjau minėti nieko, nes po to ten tie visi akronimai ir taip toliau, bet vienas iš tokių labai paprasta, turbūt, gal net ir būsit girdėję, Shapley values. Shapley values, pats metodas vadinasi SHAP, S-H-A-P. Tai yra metodas, kuris iš žaidimų teorijos metodas, kaip priskirti žaidėjui vertę, palyginti su koalicijos vertėmis ir panašiai skirtingose koalicijose, kaip jeigu kažkokios koalicijos žaidime gali laimėti prizą arba nelaimėti ir kaip kiekvienas žaidėjas yra vertingas skirtingos formos koalicijai ir imant visas permutacijas įmanomas ir taip toliau. Tai čia iš žaidimų teorijos keliasdešimt metų atgal Shapley per panašus indeksai buvo sukurti tam, jie dabar yra naudojami būtent mašininio mokymosi classifiers, kur kiekvienas žaidėjas yra feature, tiesiog yra kažkokia feature of the data ir kiek jinai yra svarbi kažkokiam outputs. Ir tu gali naudoti tą metodą, aproksimuoti ir bandyti sakyti, kad va, štai tai paaiškina, štai tokį output šito algoritmo pagal šitą Shapley metodą. Tai čia toks pavyzdys. Jeigu nori daugiau, pilna čia rasit ten tose.
Dar vienas trumpas klausimėlis ar pastaba?
Ačiū už pranešimą, tikrai labai įdomi tema. Aš tokį gal bendrą, ar egzistuoja kažkokie tai standartai, kad galima būtų tą explainability pamatuoti, ar kažkokie laipteliai, kad sakyt, vat, čia atitinka kažką, ar yra kažkokia, nežinau, pastangos tai sukurti ir ar tai įmanoma iš vis?
Ačiū, labai geras klausimas, tai trumpai pasakius, ne, standartai ne. Kiekvienam tokiam paaiškinamumo ar explainability metodui yra bandoma, kiekvienas bando pristatyti kažkokias tai metrikas, kuriamis naudojantis galima pasakyti, kad šitas metodas yra geras. Pavyzdžiui, jeigu priskirimas reikšmių verčių kažkokiam tai features, kad čia nulėmė šitą outcome, tai gali sakyti, gerai, pereini per visą dataset ir pasižiūri, ar tikrai čia yra svarbus, kiek procentų svarbus ir panašiai. Tokios metrikos, jas galima naudoti, bet jų yra daug, jos nėra bendrai sutartinos, jos dažnai viena kitai prieštarauja arba negali, skirtingi trade-offs būna. Tai dėl to yra sunku pasakyti, kuris metodas yra geresnis, vienas ar metodas yra geresnis negu kitas. Reikia tikrai bandyti paaiškinti, kodėl būtent ta savybė arba ta metrika yra tau geresnė arba kažkokia kombinacija jų. Tai čia iš vienos pusės tyrimas šitame vyksta, bet to labai reikia daugiau, o iš standartų pusės nėra jokių standartų. Dirbtiniam intelekte standartai jau pradeda atsirasti, tarptautiniai standartai. Explainable AI standartų dar nėra, bet pavyzdžiui, Jungtinių valstijų National Institute of Standards and Technology pernai metais, o gal net ir užpernai jau pačiam gale, išleido white paper apie Explainable AI standards. Mes Ericssone irgi darėm tyrimus, ką galima daryti būtų su tais ir taip toliau, bet tas procesas yra ilgas. Standartus įvesti metus, keletą metų, 5 galbūt gali metus užtrukti. Kol kas dar nėra akademinio sutarimo, kas tai turėtų būti, ir nėra dar sutarimo iš kompanijų, galbūt yra tik tai pradiniai žingsniai, kaip tai būtų gerai. O jeigu kaip kompanija perki kažkokį produktą iš kitos kompanijos Explainable AI, tai perki katę maiše. Taip, grubiai tariant. Jo, ačiū.
Dar vienas trumpas klausimas.
Sveiki. Panašus į tos standartus klausimas būtų tiesiog, kaip žmonės mes suprantam tą paaiškinimą. Mums istorija gera, jūs sutinkam su istorija, jo, maladėts. Bet kaip realiai, yra atskirtis ir reali priežastis ir mums suprantama priežastis. Tai ar yra kokie būdai, tą atskirtį matematiškai ar kažkaip pamatuoti? Nes žmogų, manau, lengva atsirasti koks super AI ir žmogų galėtų, dėl to nužudžiau senelę, nes ji nedavė šokolado. Bet realiai tai nužudžiau senelę, nes nedavė man 5 eurų. Atsiprašau, labai blogas gal pavyzdys. Bet kaip tą atskirti turėti? Ar yra kažkoks?
Labai geras klausimas irgi. Tai žinoma, kaip ir dirbtiniam intelekte bendrai, taip ir paaiškinam dirbtiniam intelekte, technologijom yra taikomi aukštesni standartai, negu mes savo žmonėm taikome, taip grubiai tariant, bent jau iš tos computational perspektyvos. Tai tų tokių metrikų ir savybių, kurias galėtum pamatuoti ir įrodyti, kad kažkokios explanations yra geros arba priimtinos arba panašiai. Jų yra įvairių, bet jos vėlgi nėra sutarta, kad tos ar tos yra geresnės, bet dažniausiai yra stengiamasi, kad tai būtų tokios savybės kaip korektiškumas, fidelity, ištikimumas turbūt arba panašiai, kad tai, ką tu sakai, kad tai yra paaiškinimas, tai iš tikrųjų taip ir yra modelė. Ne tai, kad tu čia sukūrei pasakyti kitą istoriją tokią, ką galbūt mes žmonės dažnai darom, bet tai turi atspindėti tai, kas vyksta tame modelyje, bent jau taip, kaip mes gerai tai suprantam. Kartais to nėra daroma ir dažnai tokiuose greitose pritaikomose, tai taip sakant, pasiemi metodą, kuris daugiau mažiau gerai veikia, biškį ten paeksperimentuoja ir sakai, neblogai, tai paleisim, pradėsim naudoti, bet taip, jeigu rimtai norėtum, tai ieškotum tokių garantijų, kad tau tikrai paaiškinimas atitinka ir išpildo šitas savybės, patenkina šitas metrikas ir taip toliau, kas yra šiek tiek kitaip, negu mes reikalavom iš žmonių, politikų gal. Bet geras klausimas.
Gerai, dar vienas ir paskutinis.
Dėkui. Gal turėtume trumpą komentarą apie skirtumą tarp Explainable AI ir Interpretable AI? Čia iš tos pusės, kad galbūt galima žiūrėti, jog atsakymas, na kaip per esenciją esmė jau yra algoritme, jo viduje, tik tai nėra intuityviai suprantama būtent žmogui, kažkam išoriniam stebėtojui.
Jo, geras klausimas, šitas geras požiūris. Iš tikrųjų, nenoriu reprezentuoti bendruomenės, nes to sutarimo nėra ir daug žmonių mano ganėtinai skirtingai apie šitos interpretable, explainable žodžius. Aš turiu savo supratimą ir galbūt ir kiti žmonės, jisai gana panašus yra. Interpretable model reiškia, kad galima priskirti kažkokią subjektyvę meaning, prasme arba analogiją tai technologijai, kuri ten yra, bet tai dar nereiškia, kad tu kad supranti tai, prasme, tu gali žinoti, kad ten tiesinė regresija arba panašiai veikia štai taip, arba pagal analogiją clustering method veikia štai taip, bet tai dar nėra paaiškinamas, kaip tu gauni tą modelį, kaip tu susieji įvadus ir išvadas ir taip toliau. Tai mano nuomonė, explainability yra bendresnis terminas, kuris apėmė ne tik tai, kad tu turėtum paaiškinti ir techniškai, bet apėmė ir tas savybės, metrikas ir kaip tu pateiki paaiškinimus tam vartotojui, kuris yra kokia forma, tekstas, vaizdas ar interakcija ir panašiai, ir kitus dalykus. O interpretability yra labiau apie grinai, ar tu gali kažkaip tam konkrečiam modeliui ir grubiai tariant, tai algoritmui ir matematikai, kuri ten yra, priskirti kažkokią subjektyvę, tokį supratimą, kaip mes fizikai kartais priskime ir panašiai kažkas tokio. Bet čia toks wishy-washy labai, tie terminai nėra nusistovėję ir ką aš manau, tai čia irgi geriau nevartoti abiejų vienu metu. Geras klausimas. Ačiū labai už klausimus.